This is the homework video for chapter 3, question number 33. So the instructions are, vector B has x, y, and z components of 4.00, 6.00, and 3.00 units respectively. Calculate the magnitude of vector B and the angles vector B makes with the coordinate axes. So we can write out vector B in this equation. Vector B equals 4.00 I hat plus 6.00 j hat plus 3.00 k hat. And this is the equation of the vector, and we want to find the magnitude of vector B, which is the distance from the coordinate 0, 0, 0, the origin, to each of these x, y, and z coordinates, which is 4, 6, 3. So to find the magnitude of the vector, we do the distance formula between these 2 points. So magnitude of B equals the square root of x2 minus x1 squared plus y2 minus y1 squared plus z2 minus z1 squared. Now plugging in, we get square root of 4 minus 0 squared plus 6 minus 0 squared plus 3 minus 0 squared. Then we get that equals square root of 16 plus 36 plus 9, which equals square root of 61. Now plugging that into the calculator, we get 7.81, which equals 7.81. So this is the magnitude of vector B. Now we want to find the angles angle B makes with each of the coordinate axes. So to do it with the x-axis, we do the inverse cosine of the x over the magnitude of vector B, which is the hypotenuse. So let's call the angle between the x-axis and vector B theta. So theta equals the inverse cosine of 4.00, which is the x component, over the magnitude, which is basically the hypotenuse, 7.81. We plug that into the calculator. And we get 59.19 degrees. Now between the y-axis and vector B, let's call it angle alpha, we get inverse cosine of 6.00 over the magnitude of vector B, which is 7.81, equals, plug that into the calculator again, and we get 39.81 degrees. And finally, for the z-axis, we'll call that angle beta, which equals inverse cosine of the z component, which is 3.00, over the magnitude of vector B. plug it into the calculator. And we get 67.41 degrees. And that is the answer to chapter 3, question number 33.